Let's now do example 4. What is the MacD of a 1.5-year, 4% semi-annual coupon bond with a $1,000 face value and yield to maturity of 5%? Again, let's start with our timeline. So 1.5-year semi-annual. So each increment will be half year, and we're going to have 3 of them. So we have 0, 0.5, 1, and 1.5. And 4% of 1,000, like the previous question, is 40, but this is semi-annual. So each coupon is going to be half that, so 20. And then last one is face value plus the last coupon. Now the next step is step number 2 was to find the present values. We're going to use the single cash flow, present value of a single cash flow formula, but with semi-annual. So we have to do semi-annual compounding, m equals 2. So we're going to have FV divided by 1 plus I over m raised to n by m, right? So let's write this here. This is the formula we are using for each one. FV divided by 1 plus I over m raised to n by m, right? But I will be the yield to maturity, m is 2, and n is going to be however far from year 0 we are. And our yield to maturity is 5%. All right, so the first present value is going to be $20 divided by 1 plus 0.05 divided by 2. So that's the 6-month yield to maturity, raised to 0.5. That's n, half a year, 0.5 times 2. So this is going to be 1. Okay. The second one is going to be 20 divided by 1 plus 0.05 over 2 raised to 1 times 2, 2. And the last one is going to be 1020 divided by 1 plus 0.05 over 2 raised to 1.5 times 2, 3. Okay. And in fact, these power terms will be 1, 2, 3. They are going to go in that order every time. This is coupon 1, coupon 2, coupon 3, or 1 increment, so half a year, 2 increments, 3 increments. So that's how it goes. And now let's compute the present values. Let's bring our calculator. 20 divided by 1.025 raised to 1. Store 1. That's the first one. The present value is 19.512. The second one is 20 divided by 1.025 squared, 19.036. Store 2. You can leave more decimal places. It doesn't matter for me because I'm storing everything in the calculator. And the last one is 1020 divided by open 1.025 raised to, no, that's 1025. Let me do it again. 1020 divided by open 1.025 raised to 3 close equal 947.17. Okay, and if I add these up, so this is store 3, this plus recall 2 plus recall 1, I'm gonna have $985.720. Okay, what is that? That's the value of the coupon bond, right? The sum of the present values of each cash flow. That's the value of the coupon bond. Again, do it, pause the video and use the annuity shortcut to find. You should get exactly the same number. So now we're going to compute weights. Right? Weights are each present value divided by the sum. So I'm going to store this sum as store 4, STO4. So now I can recall 1, the first present value, first cash flow divided by recall 4, and that's the weight. 0.0198. store 1. So I'm replacing, now I have the weight stored in 1. The second one, recall 2 divided by recall the sum, recall 4 equals 0.0193 store 3, and then recall 3 over recall 4. The last one is contributing about 96% to the value of the bond. And if I add these up, so store 3, recall 3 plus recall 2 plus recall 1, not surprisingly, I should have exactly 1. So 100%. Together, they account for 100% of the value. And then the last one is going to be duration of each cash flow times the weight of each cash flow. Right? So the first one is going to be recall 1 times, now this is important, the duration of this cash flow is 0.5. Right? So this is going to be this weight times 0.5, 0.0099, store 1. So I replace, again, I need this number later, so store 1. Recall 2 times 1, it's the same thing, 0.0193. I don't have to do anything about that. Recall 3 times its duration is 1.5, 1.5 equals 1.4413, store 3. All right, so now if I add these up, this plus recall 2 plus recall 1, 1.471 rounded. 1.471 years is the MacD of this coupon bond, and it's quite a bit less than the previous one, meaning that if the yield changes from 5% to something else, the price of this bond will move much less than the price of the bond that was in example number 3.